Moving on to our second subtopic of chapter 3, which is periodicity. At the end of periodicity, you're gonna learn how to describe the variation in atomic radii across a period, across the first row of transition elements, and going down a group. In periodic table, there are three factors that should be considered, which are energy level and the second factor would be the effective nuclear charge. So the symbol is ZEF, we call it as ZEF. The last factor would be shielding or screening effect. Okay, you can write either shielding or screening effect in examination. So what do these factors influence? Both energy levels and shielding effect have an effect on the group of elements. Meanwhile, the effective nuclear charge or ZEF has an effect on a period. Okay, first we have to be clear on the definition of nuclear charge. Nuclear charge is the total charge of all the protons in the nucleus. Okay, so it is just the same value as the atomic number or proton number. So it describes the charge of nucleus that pull electron closer towards it. The trend would be when the number of protons increase, nuclear charge also increase, and that will result a stronger attraction between nucleus and outermost electron. Okay, class, I want to remind you that you can't just write attraction will become stronger. No, you have to write attraction between what and what. Okay, that is the attraction between nucleus and outermost electron becomes stronger. Okay, so I'm highlighting the word nucleus and outermost, which means that it is compulsory to have that in your answer. Effective nuclear charge or ZEF. Okay, remember to write the EFF as a lower transcript. Describe the net positive charge felt by an outermost electron. ZEF has a formula of Z minus S, where Z is the proton number, whilst S is the number of inner or core electrons. Let's take a simple example of fluorine. So fluorine has 9 proton number. So we're gonna draw the orbitals first. And so we go by the first. This is n equal to 1. The first shell should be fulfilled by how many electrons, class? Yes, 2 electrons. So how many electrons is needed to fill the second shell or second orbital of fluorine? Yes, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have an illustration of fluorine shell. Okay, so now let's calculate your ZEF. So the ZEF of fluorine would be the proton number, which is 9 minus, okay, is it minus 2 or minus 7? So the first shell of fluorine would be the inner shell, and this would be the outermost shell. Okay, so what is the number of inner electrons for fluorine? Yes, that will be 2. So 9 minus 2, we've got positive 7. Okay. So the effective nuclear charge for fluorine is positive 7. So you have to write this positive number as well, indicating that there is a net positive charge of ZEF. Let's compare the effective nuclear charge of sodium with a proton number of 11 and chlorine with a proton number of 17. We're going to use 2.88 rule to clearly portray the effective nuclear charge. So sodium has the 2.81, whereas this chlorine would have 2.8.7. Now let's draw the shell of sodium. The first shell will consist of 2 electrons, and the second shell consists of 8 electrons. And the last shell only has 1 electron. So the first and the second shell consists of the inner electron, and the outermost shell consists of the outer electron. For Cl, the first shell consists of 2 electrons, the second consists of 8 electrons, and the third shell consists of 7 electrons. So what is the ZEF for sodium? The formula for ZEF is Z minus S, where S is the inner electron. Hence, ZEF is the proton number, which is 11, minus the inner electron, which is 2 plus 8. That would be a positive 1. For the chlorine, the ZEF would be 17 minus 10. Okay. 17 minus 10, which is for 2 plus 8, the number of inner electron. So that would be positive 7. So which one has a higher ZEF? Is it sodium or chlorine? Yeah, chlorine would have higher ZEF with a net positive charge of positive 7. So we can conclude that for sodium and chlorine, even though they have the same number of shell, which is 3, and the same number of inner electron, which is 10, they have different depth, where chlorine is higher than sodium. So we can say that the attraction between nucleus and outer electron in chlorine is stronger than sodium. Shielding or screening effect. Shielding effect describes the attraction between nucleus and electron in any atom with more than one electron shell. So it only involves atom which has shells more than one. In short, it means that the electron in inner shells will screen or shield the electron in outermost shell from the full effect of the nuclear charge. And this is because the electrons on the outermost energy level has to look through all the other energy levels to see the nucleus. And this will explain the shielding effect. I know you have enough of the words, so I'm gonna make it simple for you because chemistry is not that hard, okay? So let's say that I have two artists, which is Siti Nohaliza with electron number of 11 and Taylor Swift with electron number of 3. Okay, so let's say both has two stalkers. Okay, which represent the nuclear charge. So stalkers represent the nuclear charge. So now let's fill in the shell for City and Taylor. For City, I'm gonna start with 2, 8, 1. Okay. So the first shell should be filled with 2 electrons, followed by 8 electron. And lastly, the outermost electron would be the City Nohaliza itself. Okay. And let's draw for Taylor Swift as well. Okay, so Taylor has the 2, 1. Okay, so let's fill in the shells together. So the first shell should be filled with 2 electrons. And the outermost shell is occupied by Taylor Swift itself. So this inner electron represent the bodyguards. Okay, you know that when you are famous, lots of people wanna disturb you, so you need to have a bodyguard. And City and Taylor Swift would be the outermost electron. So right now I want to ask you, so who's gonna be disturbed more by the stalkers? Is it Siti Nohaliza or the Taylor Swift? Who has more bodyguards or more inner electron? Yes, that would be city. Okay. So city has more inner electron, or in other words, more bodyguards. Hence, it will be shielded by the nuclear charge, which represent by the stalkers. Okay. So shading effect is about who has the more inner electron, or bodyguard should has a higher shading effect. So in short, the shading effect will increase if the number of shells increase. Like for City, she has 3 shells compared to Tyler, which has 2 shells. And shielding effect will also increase whenever there is an increase in the number of inner electron. Okay, because City has more bodyguards, which is 8, which is 10 bodyguards in total, whereas Tyler only has 2 bodyguards. So we can say that when the number of shells increase, the number of inner electrons will increase as well. Hence, shielding effect will increase. So what will happen to the attraction when shielding effect increase? The attraction between a nucleus and outer electron will become weaker. Okay, let's take a look at sodium and potassium. What is the difference between their shielding effect? So for sodium, the number of shell is 3, whereas for potassium, the number of shell is 4. Okay, so it is bigger than sodium. So we consider the attraction between the nucleus and the outermost shell and the outermost electron. So who will have a weaker attraction between nucleus and the outermost electron? Who has a bigger gap? Okay, that would be who has a weaker attraction between nucleus and outer electron. So the attraction between nucleus and outer electrons in sodium is stronger than potassium. Just a final highlight. Again, nuclear charge is definitely not same with effective nuclear charge. Because nuclear charge describes the charge of nucleus that pull electrons closer towards it, whereas effective nuclear charge or ZAP is the net positive charge felt by an outermost electron, which can be calculated by a formula.